On July 20, 1969, two human beings stood on a world that was not Earth. The moment was brief compared with the scale of history: a ladder, a dusty footpad, a gray surface, and a voice carried across space to hundreds of millions of people listening at home. But Apollo 11 was not only a dramatic television event. It was the result of years of engineering, political pressure, risk, tragedy, and determination. The mission lasted just over 8 days, from launch on July 16 to splashdown on July 24, yet it became one of the defining achievements of the 20th century. For the first time, humans left their planet, landed on the moon, walked on its surface, collected samples, and returned safely. To understand Apollo 11, we have to look beyond the famous footprint and ask how such a mission was possible at all. Apollo 11 was born in the pressure cooker of the Cold War. The United States and the Soviet Union were not simply exploring space for science, they were competing for technological and ideological prestige. Early in the space race, the Soviet Union had major successes, including the first artificial satellite and the first human in orbit. In 1961, President John F. Kennedy set a bold national goal: before the decade was out, the United States would land a man on the moon and return him safely to Earth. That final phrase mattered. A landing alone would not be enough. The mission had to bring the crew home. Apollo 11 was the fulfillment of that promise, but it stood on the foundation of earlier NASA programs. Mercury proved humans could survive in orbit. Gemini developed rendezvous, docking, and spacewalking skills. Apollo would have to combine all of it on a far larger scale. The crew of Apollo 11 consisted of 3 astronauts, each with a distinct role. Neil Armstrong was the commander, responsible for the mission and ultimately for piloting the lunar landing. Edwin Buzz Aldrin was the lunar module pilot, trained to operate the craft that would descend to the moon's surface. Michael Collins was the command module pilot, responsible for the spacecraft that would remain in lunar orbit while the other 2 astronauts landed. All 3 were experienced, calm under pressure, and on what would become their second and final spaceflight. Their job required more than bravery. They had to master spacecraft systems, navigation, emergency procedures, geology training, and precise timing. The mission depended on teamwork across a distance of nearly 400,000 kilometers from Earth, and on trust between the men in the spacecraft and thousands of engineers and controllers on the ground. Apollo 11 launched from Kennedy Space Center in Florida on July 16, 1969, at 13:32 Universal Time Coordinated. Beneath the astronauts was the Saturn V, still one of the most powerful rockets ever built. It was not a single vehicle so much as a tower of controlled explosions, built to lift a complete lunar spacecraft out of Earth's gravity. The launch was a carefully staged process. The first stage burned enormous amounts of fuel to climb away from the pad. The second stage continued pushing the spacecraft toward orbit. The third stage first helped place Apollo 11 around Earth, then reignited to send it toward the moon. This maneuver, called translunar injection, transformed the mission from an orbital flight into a voyage across deep space. After years of preparation, Apollo 11 was finally committed to the moon. The Apollo spacecraft was actually made of several connected machines, each designed for a specific job. The command module, named Columbia, housed all 3 astronauts during most of the mission and was the only part that would return to Earth. Attached to it was the service module, which supplied propulsion, electrical power, oxygen, and water. Together, they formed the command and service module. Then there was the lunar module, named Eagle, a strange-looking craft built only for space and the moon's weak gravity. Eagle had 2 stages. The descent stage carried fuel, landing legs, and a large engine to slow the fall toward the lunar surface. The ascent stage held the crew cabin and a smaller engine to lift Armstrong and Aldrin back into lunar orbit. Every part had to work at the right time, because there was no rescue ship waiting nearby. The trip to the moon took about 3 days. During that time, the crew lived inside a compact spacecraft, performed system checks, and adjusted their path with carefully planned engine burns. Spaceflight was often described in heroic terms, but much of it was disciplined routine, monitoring gauges, reading checklists, eating packaged food, sleeping in shifts, and staying alert for any sign of trouble. The journey also required an important maneuver soon after leaving Earth orbit. The command module separated, turned around, docked with the lunar module, and pulled it free from the rocket stage that had sent them toward the moon. This step joined Columbia and Eagle nose to nose for the coast outward. As Earth shrank behind them, the astronauts became some of the few humans ever to see their home planet as a distant, fragile sphere. When Apollo 11 reached the moon, the spacecraft entered lunar orbit. This was a new phase of risk. Armstrong and Aldrin moved into Eagle, while Collins remained alone in Columbia. The two spacecraft separated, and Eagle began its descent toward the Sea of Tranquility, a broad lunar plain chosen because it appeared relatively safe and flat. But the landing was not simple. As Eagle descended, Armstrong saw that the automatic guidance was taking them toward a field of boulders. With fuel running low, he took more manual control and guided the lunar module toward a safer spot. Mission Control watched the numbers with rising tension. Finally, on July 20 at 2017 Universal Time Coordinated, the call came, the Eagle has landed. That sentence meant the impossible had become real, but it did not yet mean the mission was complete. For more than 6 hours after landing, Armstrong and Aldrin prepared to leave the lunar module. The first moonwalk was not a spontaneous step outside, it was a carefully managed operation involving pressure suits, life support backpacks, communication systems, and depressurizing the cabin. When Armstrong climbed down the ladder and placed his boot on the surface, he became the first human to stand on the moon. His words, "That's one small step for man, one giant leap for mankind," instantly entered history. Aldrin followed about 19 minutes later. Together they moved in a world with 1/6 of Earth's gravity, where every motion felt unfamiliar. The lunar dust held footprints sharply, the horizon looked close, and the sky above them was completely black. For the first time, another world had human visitors. The moonwalk lasted about 2.5 hours, and every minute had value. Armstrong and Aldrin planted an American flag, a symbolic act rooted in the space race, but they also left a plaque stating that they came in peace for all mankind. They spoke by radio telephone with President Richard Nixon in the White House, a conversation that connected the lunar surface to Earth politics in real time. More importantly for science, they collected 21.5 kilograms, or 47.5 pounds, of lunar material. These rocks and soil samples were not souvenirs, they were evidence. They helped scientists study the moon's formation, its volcanic history, and its relationship to Earth. The astronauts also deployed instruments designed to continue working after they left, turning the landing site into a scientific station rather than just a destination. While Armstrong and Aldrin explored the surface, Michael Collins orbited above in Columbia. His role is sometimes overshadowed by the moonwalk, but the mission depended on him completely. Collins maintained the command module, checked systems, and prepared for the rendezvous that would bring the crew back together. During each orbit, he passed behind the moon and lost radio contact with Earth, becoming one of the most isolated humans in history. If Eagle's ascent engine failed, Collins could not land to rescue his crewmates. If Columbia developed a serious problem, Armstrong and Aldrin might have had no way home. Apollo 11 was a chain of interdependent steps, and Collins guarded the link between lunar adventure and survival. His quiet orbit was as essential as the footprints below. After more than 21 hours on the lunar surface, Armstrong and Aldrin prepared to leave. The lower descent stage of Eagle remained behind, while the ascent stage lifted off using its own engine. This was one of the mission's most critical moments. The small craft had to rise from the moon, enter orbit, and meet Columbia with enough accuracy for docking. There was no room for improvisation on a large scale, the geometry and timing had to work. Eagle successfully rejoined Columbia, and the astronauts transferred themselves, their samples, and essential materials back into the command module. The lunar module ascent stage was then no longer needed. With the crew reunited, Apollo 11 fired its engine to leave lunar orbit and begin the long return toward Earth. The landing had made history, but the promise Kennedy had set required safe return. On July 24, 1969, Apollo 11 returned to Earth. Only Columbia survived the fiery re-entry through the atmosphere, protected by its heat shield as it slowed from tremendous speed. The command module splashed down in the Pacific Ocean, where recovery teams were waiting. The astronauts were safe, and the mission was complete. The global reaction was enormous. Armstrong's first steps had been broadcast live to an estimated 600 million viewers, roughly one-fifth of the world's population at the time, making it one of the most watched events in television history. The crew received parades, a World Goodwill Tour, and the Presidential Medal of Freedom. Yet beyond celebration, Apollo 11 also left a lasting scientific legacy. Its samples revealed previously unrecognized minerals, and instruments on the moon returned data for years. Columbia is preserved in Washington, D.C., while Eagle's descent stage still rests silently on the lunar surface, a monument to the moment humanity first reached another world. If you found this helpful, please like this video and subscribe for more explainers.